Welcome to Brainiac's Academy. Let's master periodicity. We will make understanding the periodic table and trends simple.
So in this video, we'll be looking at periodicity, part 1. Are you with me now? Periodicity, part 1. So, alright, in this video, we'll be looking at, the history of periodicity. Let me write it out. The history, just what you need to know. And we'll look at, our trend. Okay, we look at the blocks first, then look at the trends. So what I'm going to be doing here is actually going to be a summary of periodicity, the periodic table. So if you want the full experience, you would have to register for our premium tutorials. And while you do that, ensure you subscribe to the channel, because once the videos here are actually free of charge, you can actually learn. This one is just just for you to get some insights, some tricks, some mnemonics and all. So it's going to be very useful. So if we should drop a video, you will be notified, so that you'll be notified immediately. So that's why it's very important for you to like and subscribe. So okay, let's go. What do you need to know? What do you need to know under periodicity? What do you need to know? Now, the history now. Let's take the history. You see, this history was, this was the history of periodic table, coined by my guys. My guys, who are these my guys? The very first one. I think we don't need to talk about this very first one. The Anthony Lavoisier, how that we have Johanan Dombere, Basilius who assigned our elements. Are you with me now? Basilius who assigned our elements, as well as John Newland. But those ones I want you to just leave them aside. So the key, those people that I want you to now know about now, these are the people they would ask you in your JAMB or Post-UTME. Now follow closely. When you have our father of periodic table, which is Dimitri Mendeleev. Are you with me? Dimitri Mendeleev. You see, Dimitri Mendeleev is the father of periodic table. So this is the father. And when he was actually classifying elements in the periodic table, he actually classified based on their atomic masses. When you talk about atomic masses, he also said, arranged in order of their atomic weights. So when you see the word atomic mass or weight, just don't be confused. So it was still the one that talked about that. Okay, let's arrange these elements in their order of increasing atomic masses or increasing atomic weights. So that's what Dimitri Mendeleev said. But my guy, the other guy now came, which was Henry Moseley. Oh my Jesus. Henry Moseley. And this Henry Moseley is actually the one that now came and reversed what this one said. He said, "Guy, you are my father, I respect you, but you are not correct, sir. You are the father that bettered periodic table, but you are not correct, sir. Because how would you tell me that you arrange them in order of increasing atomic mass? That's inaccurate, guy." He was talking to the father of the whole periodic table. Then what did Henry Moseley now did? Henry Moseley now made us understand that these elements are actually arranged in their order of increasing atomic number. Bear with me, I'm actually teaching you guys like a lecturer. So atomic number, you guys I believe you've read this thing before. Just come for backup, just for backup to lock it in. Are you with me now? So Henry Moseley did what? Arranged in order of what? Atomic number. Let me change my marker. Are you with me now? Let me change my marker so that you guys can see. So atomic what? Atomic what? Number. Are you with me now? Somebody type JAMB is in trouble. JAMB 2027 is in trouble. So yeah, atomic what? Number. So that's it. That's what Henry Moseley. So which brought him to his law, the modern law, that says elements are a periodic function of their atomic number, which is our periodic what? Periodic law. Are you with me now? We have a very long way to go, and this is just periodicity 1. So periodicity 1, we have a very long way to go. That's you have to subscribe, so that when I drop periodicity 2, you're able to understand the lot. Alright, so periodicity 1 is just for some basic things you need to know. So alright, so that was what brought us to our modern law, modern periodic table. Now there was this periodic table we were using before. Sure you get. But then let's make it simple. I think that's all you need to know under history. Do you still need to know anything more? No. Just leave others. See these two key, they are very key. They are very key. The father and the one that came after and made us understand that we need to really, change what the father said. So now let's check blocks. So we are done with this. Let's check this. Alright. Now, what I'll do is that I'll draw this periodic table for us. But before I draw it, I want you to know something. This laptop? Who knows my laptop? What's the name of the laptop I'm using? If you know the name of my laptop, then you understand this periodic table well. And okay, I'm using HP laptop, right? And HP is a very good laptop. Or is it a bad laptop? It's a good laptop. And if you have anyone that want to buy me iPhone laptop, that's so I'm using HP what? Laptop. Now, this is it here. Let me write it for you. HP is a what? Is a very good laptop. Are you with me now? HP is a very good laptop. Meaning that our period, this period, is arranged horizontally. Are you with me now? While my group is arranged vertically. HP is a very, let me put my V there, is a very good. So my vertical, all those vertical elements that are arranged vertically are my group, while my horizontal elements, those ones that are arranged, in column are, my period. So HP is a very good laptop. Let me now draw this basic first 20 elements table so that we can use it to explain this. Alright, we have hydrogen, then you come here, then you drop He. But then let's first, this is group 1, this will be group 2, then group 3, 4, 5, 6, 7, 8 or 0. Okay, let's clean this one. Let's come back. Hydrogen, helium, lithium, beryllium, boron, carbon. I believe you guys can draw this thing, oxygen, fluorine, then neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So guys, I believe you can see this thing very well. Guys, now look at this now. You see those ones coming like this. Those ones coming like this. That is coming like this are your what? Your vertical side. These are your vertical side. Are you with me now? Let me complete it. Vertical side. Now let's check for our horizontal side now. My horizontal. So this is my horizontal side. Horizontal side, which is my period. Horizontal. Don't draw rubbish. Wait. Let me check first. Oh, sorry, this one should come up because I was like, something is odd here. So hydrogen, your helium here. So yeah, continue. Don't yet close marker. So yeah, so look at the arrow. So here now, you can see that this what, look at the arrows. This one coming down like this is your vertical. I don't know if you guys are getting the scope. That is your what? Your vertical. Alright? So now, we now have something called row and column. So those ones pointing down is your column. Are you with me now? This one's like this. Coming down. Coming down are your what? Column. Like H column, lithium column. So these are your column. Then your rows. Like you still are in a class. You now see that first row, second row, third row. Sure you guys get like that. Now let's check. Let's check. These are our group 1, group 2. Alright, like vertical. Group 3, group 4, group 5, group 6, group 7, and then group 8 or 0. Now there is this modern classification that brought us to group 11, 12. So this one here can be written as group 11A or B, 11A or B, group 12A or B, but these ones are A actually. All these ones are for A. I will draw the one of combination of both A and B. And that's the accepted one, so that we can be able to like get our SPDF. So now 12A and B. So group 13A. So you have group 13A, 14A, 15A, 16A, and 17A. Pardon me for managing my board though. I don't want to be cleaning. That's why. Oh, hope you guys can even see it. If you cannot see, this one is just group 11A, 12A, 13A. Like 11A is another, like you just adding 1 at the back of all these normal numbers, group 1, group 2, group 3. Now let's now check our group 1. Don't forget where we are coming from. HP is a very good laptop, meaning that our horizontal component is the period, while our vertical component is the group. Now look at group 1 now. How do we know group 1? Let's come back to this place. Our HP, can you see it? HP is a very good laptop. HP equals VG. So this HP here, H is horizontal, right? And anything period, what you should go and look for is the shells. Can you see what I'm writing? The shells or energy level. If you have watched the video on hybridization and calculation under quantum numbers, then you would understand what I mean by shells or energy level. So I don't need to digress. I don't need to digress. Let's just continue. If you know you don't understand what shells or energy level, just find your way to that video and go and watch. Now, very good here. That's your vertical, your group, Abi. Your group is the vertical component. So this one, when you see group, anything group, what you should look for in your option is, the number of electron in the outermost shell. Permit me to short it. Number of E. Number of what? E. Do you catch that at all? Number of electron in the element outermost shell. That's all you should go and check for. Now, for example, let's experiment it. If you have, let's just pick elements from here. Let's pick elements from here. Now we have sodium, potassium. Let's pick sodium, potassium. Then let's pick here too. And let's pick here nitrogen and oxygen. Okay. Sodium. Let's pick sodium and what? Potassium. Now, how are you going to draw the shell? Talking about shell, you are talking about your KLMNOPQRS shell. So for our level, we are dealing with KLMNO. Now these are shells. Now coming back here, let's try to draw the shell of sodium. So we can use it to like maybe get if they are in the same period, or like, okay, let's say to get the period of sodium and to get the group of what? Sodium. Now draw the shell. And it is that shell that you would use to what? Check for the period. Please don't forget all these things. But the electron in the outermost shell of sodium is what will determine the group. Let's quickly draw first. Now, your small your small nucleus, which will carry what? And sodium is what? Sodium is 11, right? Which is written as your 2/8 of 1. I believe we know all these things already. We don't need to. Do we still need to waste time on them? Do we still need to waste time on them? I don't think so. I don't think so. I don't think so. So 2, 8, 1. So now 2, 1, 2. All right. Then the second shell. This is the K shell like that. Now let's move our L shell, which is 8. Abi, draw it. 1, 2, 3, 4, 5, 6, 7, 8. Now the last shell is 1. Alright, just draw the last shell and add 1. Meaning that we have 2, 8, 1. 2, 8, 1. 2, 8, 1. Meaning that we are having only KLM shell here. We are having only KLM shell here. And this is our K shell. Let me get my marker. Let me get my marker here. Let me get my marker here so that I can actually now. So meaning that you are actually having how many shells? You are having K, L, M, like 3 shells. Are you with me now? From your let me even zoom. Let me zoom this thing. Oh, because I don't think you guys are seeing this thing now. Let's zoom a little bit. Let's zoom a little bit. So KLM, alright. So KLM, alright. KLM shell. Now that's it though. Please, I don't want this video to be long, so let me move. So that from my 281, I got the number of shell. Now what's the group? What's the group of sodium? Sodium group. And what's the period? So this my marker is finished already. Oh my god, oh, what's going on? Okay, let's change marker again. So for group and period, right? So group here now, how are we going to know the group of sodium? I told you number of what electron in the outermost shell of an element will determine its group. Now which group is this? Let's check the number of electron in the outermost shell. Of course, this is the number of electron in its outermost shell here. Are you with me now? So this one, that means it's in what? Group 1, G1. And can you see G1? Oh my god, chemistry is simple. You are actually going to score high. Now, period. How am I going to know my period from this element, from this particular element? Now, the period is actually telling us the number of shells. The number of what? Of shells. Now, how many shells are we having? 3. Then that means this one is in what? Period 3. Now, check. Where's period? Where's period 3 here? Now, this is period 3. Let's label it also. Let me use red pen. This period 1, period 2. Wow, period 3. Wow. So I know book. Oh my Jesus. So me too, I know book. Oh. So period 3. So guys, do for potassium. So if you do for potassium, drop your this thing. Drop it in the comment section, and that will motivate me to create many more videos for you. I know that people are following. I know that yes, people are following. So good one. Is that all? So if you pick any elements here now, you can actually tell us the group and the period. So you can do for your barium. Yes, do for your barium. Premium students, they know the group. They even know the group without solving. So you can do for barium, you can do for strontium. We are raising academic giants, so you should be able to know this one. Do for barium and strontium. Then let me help you. You can do for fluorine, do for chlorine, and do for boron and oxygen. So yeah, let's move because of our time. Do I need to clean the board? I think I would need to clean this board a little. Oh my god. Okay. Okay. I think I need to clean this body so then we should look at a few more things and we call it a session. Before I clean this board, let's talk about the names of these groups. Now, group 1 elements, take note. Group 1 elements are your what? They are your alkali family. Are you with me? Alkali family. Now, okay, alkali metals. Sorry. Then group 2 now be what? Your alkali earth metals. Alkali earth metals. Then your group 3 would be boron family. Are you with me now? Why your carbon? That group 4 there would be your carbon family, and also this carbon family is also called crystallogenes. Crystallogenes. Crystallo what? Crystallogenes. Because in when you get to maybe post-UTME exams, they might be asking you some stuff. Now I'll be like, oh, what's this one? So group 5 would be what? Your nitrogen family is your nitrogenes. Nitrogenes. That's why they call post-UTME exams advanced. So nitrogenes. So this are what that are referred to as the nitrogenes. Now, what about group 6? Who can tell me what's group? You know, this is oxygen family, normal. But we have another name. Who knows this thing? Who know this thing? Who know this thing? Your chalcogenes. God bless you. If you know it, you should have dropped it. Chalcogenes. Alright. Drop in the comment section. Charcoal. Good. Chalcogenes. Now, group 7. Oh my God. Are these not the salt formers? Are these not the halogens? Oh my Jesus. These are the halogens. Oh my Jesus. That they love hydrogen like mad. So this is my halogens. And halogens are also called what? Salt formers. Now, our aerogenes from AR here, you know that these ones, they are just aerogenes. So aerogenes, or you call them noble gases. So I think I can clean the board now. Is that all? Can I clean this board now? Just group 1. You know, group 1 and group 2, they are S block. Group 1 and group 2 are S block. Then from 3 downwards, they are P block. Now, for D and F block, I'll have to draw the complete modern periodic table for you. So I can actually show you how that the D block would be actually in the middle of group 1 and 2 and 3 to 8A. Now, and how that your lanthanide and anthanide would be, located, somewhere below this place. Are you with me now? So that's what these are all the things we'll be looking at in periodicity 2. But before we go, are we done? Let's just check for trends. So I think after these trends, then we should go into periodicity 2 like that. Is that okay? So alright, let's talk about trends. Trends, Abi. Okay, trends is very simple. See, there's something about trends that you guys do not know. You guys will just, these are things I wish I knew, but then let's go. Let me show you the secret. There's one secret. Somebody type secret. Type it and drop it in the comment section. That's how we energize me to create more videos for you. Now, trends, Abi. My trends. Let me use my formula. DAMI, DARMI is equals to I square E square. Equals to what? I square E square. In which this one would go for DD, DP, the DP on my phone. Let me use, these are things you need to code in. And I believe you have your mnemonic book already. These are what you just revise, just one night to your exam and you just smash it. These are secret I use for my student too. So just this one, DPO, your direct profile picture. Then direct profile picture, Abi. Then what's this guy's name? This Inspector General of Police, Abi. My IG, Honorable IG of Police is Dami. Dami is what? The Honorable IG. Dami is the Honorable what? IG of Police. Then my I square E square. This one would go for, let me use my second marker. This one would go for my DD. That's David and Daniel. David Daniel Daniela. Oh my God, what is such a beautiful name. David Daniel Daniela. Oh my Jesus. David Daniel Daniela. David Daniel Daniela. Then reverse will be the case for I like that. Reverse will be the case for I like that. So now. What do I mean that Dami is the Inspector General of Police? How do I know that Dami is the Inspector General of Police? And how do I know that he's having a direct profile picture? This is it now. See, your A here is what? Your atomic radius. Your atomic radius. Are you with me? R here is your what? R here, let's just add it. R here is your reactivity. Yes, reactivity of metals. Sure you get. Then M here is your metallicity. Metallicity. Is it metallicity or metallic radius? We have metallicity. Metallicity. Then we have our ionic radius. Ionic radius. All these are what are the properties of your periodic table. Can you see how we actually brought 1, 2, 3, 4 properties of periodic table inside one name? Do you understand that logic? Now this one now, these are another properties. Oh. We have I square, I square. We have our ionization energy. I here is what? Ionization energy. While E as our electron, what? Affinity. Affinity. Can you guys see this thing? Or the marker is already looking shaky. Then we have electron negative. Do you guys get the logic? Oh my God, you must know book. Me I have no book. Oh my Jesus. And there are still a lot to learn and unlearn and relearn. Oh my Jesus. Oh my Jesus. There are still a lot of things to us learn, relearn, and unlearn. Are you with me now? So okay. So now let's come back. Academic comeback. Let's come back. Now. So let's now trace this thing back. Let's trace all this back. Now, tracing my atomic radius back to this formula now. As if you are solving physics. You are tracing this atomic radius to this dp. That means it's actually decreasing across the period. And it is increasing down the group. You know that normal your group is vertical. Group is vertical from HP. HP is a very good laptop. You know that your group is vertical, right? And then you know your horizontal. Your horizontal is your period. From HP is a very good laptop, alright? HP is a very good laptop. So good laptop here is like your group is like vertical. Very good laptop. Very good, like your group is vertical. Your group is what? Vertical. Then your horizontal being the period now be for HP. Let me just add. I've mentioned this in a number of times now, so you should know. So now that means that for something to, like, for a group would have to go down and a period should be across. So that means this one decrease across the period, while for the group it would increase down the group. Are you with me now? So same thing for your reactivity, same thing applies to metallicity, same thing applies to ionic radius. So all these things, you don't need to now be cramming and be assuming. Many of you would have taken JAMB and you now see that inside exam, be like, I've read this thing, no. Is it ionic radius exactly the same thing with metallic radius? Is it the one that is having, which one? See, use your formula, your dummy. Who is the DP? Is having a direct profile picture and is the IG of police, Inspector General of Police. So now, Inspector General is telling you that all these people here, they are actually increasing down the group while they are what's decreasing across the period. Oh my Jesus. Now let's go to the second part. Second part is telling you about I square, E square, I square, E square, I square, E square. Even without anything, you know that all these four people, they will do the reverse opposite of this DP, IG. Now, what will be the reverse opposite of DP? The reverse opposite of DP will be DD. Can you see the DD here already? What's the reverse opposite of? So even if you don't know this one, if you just know this one, in one way or the other, you are actually solving physics. Your brain is solving physics. You just use it to decode this one. Then when you read it multiple times, then you get mastery that share this one small thing. Sure you get. So the reverse opposite of DP here would be DD here. The reverse opposite of IG here would be your IP here. IP, let's put it here. I of P. Sure you get. That means okay. Wait. So alright, so that means this one is actually decreasing down the group. Ionization energy, electron affinity, electron negativity, they're actually decreasing down the group while they are increasing across the period. Oh my Jesus, do you guys get this thing? So now in periodicity, that's all for periodicity 1. So if you want to reach out to me for classes, if you want to register for premium classes, if you want to register for premium classes, just reach me. That's my phone number there on WhatsApp. And when you message me, ensure you go straight to the point. I want to register for JAMB tutorials, intense word locking. We are going to be locking in intensely. So alright, yeah, that's it. So in periodicity 2, we talk about various how these elements are actually increasing down the group and how they are decreasing across the period. We're looking at the increasing order of some elements, maybe increasing order, maybe taking group 7 as an example. We'll actually look at it from your FBI. So you don't miss this class. So FBI, so chlorine will be here, pam. So then we just look at the increasing order of electronegativity. Maybe they give you something like this in your JAMB, we look at the increasing order of the electronegativity. We now look for the decreasing order. It's very simple. Or maybe they give you something like this and they say you should look for the ionization energy, the increasing order of ionization energy. Then we look at it there also. So that's why you must not miss it. Don't even miss it. Because that's why we actually draw the modern periodic table. We actually look at how elements are being classified, how that would have 118 elements in which 78 are metals, while others are what? Metalloids and non-metals. Sure you guys get. So please don't miss it. Subscribe, like and share. When you subscribe, it would help you. It would help you get notified that okay, this guy has released another video. This guy has released another video. And ensure comment that comment would energize me that people are actually I can't fail these people. Let me stand up and do more. Are you with me now? So expect a lot in periodicity 2. So periodicity 2, you identify your S block, P block, D block, and F block. So and all those things. All right. That's surgical medic and his routine for you.